Welcome everybody for the artificial intelligence course session. So let me first say a few words on what we did in Leiden, so that maybe we have a bit clear how we approach these things, because it seems that every partner has a bit of different approach on this course training and the courses in general. So in Athens, we made the course description for the core course, and when we met in Leiden, we had the description also for all the electives and the training courses. And then based on that description, the groups who made the description made also the course structure. That is, we divided the course in lectures and unit, so that could be immediately uploaded into the virtual environment. And then the idea was that we had to prepare, all the European part, we have to prepare these slides for this course based on the structure of the course. Of course, things do not always fit 100%, so we had maybe from time to time we had to change something. So our approach is we took basically the structure of the course, and then we try to see how far can we go with preparing slides for that. I have to say that we have assigned the 6 courses for Leiden. So they were artificial intelligence, distributed system, recent trends in machine learning, knowledge representation, multi-objective optimization and decision analysis, and computational linguistics. So it was quite a lot of work. It was instructive too, but it was quite a lot of work for 6 courses and all the slides for all the lesson. So that's, but at the moment, yeah, we succeeded. There is only 1 course, but it will be uploaded, these days. So before the presentation will be uploaded by Jan. So, but for the rest is we upload all the material, and it was quite a lot of work because all those courses, basically, we had no such courses already present in Leiden itself. That means that we had to really prepare or to look around for slides. And of course, it's not that we in Leiden, we don't teach artificial intelligence, because we do, and we do quite a lot, but we have a different approach. And then maybe the material that is presented in these courses is spread out in different places. So we had to take slides here, slides there, and make things, put things together. So that said, yeah, we try to find all the material also from sources around the world. And what we did, we took basically the file of the structure of the courses, and we enriched it with the information about where we took the slides, so that the credits must go to those people who prepared the slide, not us. We are only those who took the slide, put things together. And then we created all this packet of slides that is, again, basically the idea is that those slides that we present now for the course are just a kind of idea, starting point that everyone of the Asian partner can use for making its own slides. So you can just cut and paste whatever you want from those slides, and you can use as a structure, you can use as an idea, or how to organize your course. But at the very end, we believe that the teacher itself is the one who has to prepare the slides. It's very hard to give a course on slides which are prepared by someone else. So you have to prepare, someone has to prepare the slide. That doesn't work that way. So nevertheless, so we have the full slides, the packet of slides is available. Some are in PDF, some are in LaTeX and PDF, some are in PowerPoint. We are in the process of translating almost everything in PowerPoint if you want to. So that's a possibility. But yeah, so that it's easy maybe to just reuse the slides in the way you want. One of the problems that we encounter in general, let's say not only for this course artificial intelligence, is that when preparing the description of the course and the structure of the course, yeah, people are typically over enthusiastic and they put a lot of idea and material there. But then when you try to organize the slides of the course, you see that that's really a lot, and makes really an enormous amount of slides that is impossible to treat within 20 hours of a course like typically is for all the Asian partners. So that means sometimes the slides are really too much, and then the teacher itself has to decide which slides you have to take it, where you want to put the accent in one part or in another. So I will try to make this say something about this when we present the slides. Okay, so that's say that I say that maybe I can start with presenting a bit the artificial intelligence. So that was maybe one of the easiest one because it's a standard course. So this is, even if we do not have it in Leiden as a master course, of course we have it some similar course for a bachelor, and yeah, well, but we made it in a different way than what we use in the bachelor, but the material is there, it's already present there. So maybe I can share the slides so that the slides. Let's start with sharing the structure maybe, and we can discuss. We can start the discussion from there. I must say that Jan van Rijn is here also to help me. So questions can be addressed to me or him. And even if I must say that this course has been prepared by Frank Takes, who is not present here at the moment. Yeah, for us here in the Netherlands already the holiday period already started. The south of Europe maybe a bit later, but we will start working back around 15th of August. So that's for the moment we are almost in the holiday period. And I know in Thailand it's completely different, so that and the other country will be even more different. Okay, so let me try to share the slides, and now to find which one, blah, blah, blah. Yeah, so let's start with this one. I hope you can see it. Can someone make a sign that they see it, even if I don't see everyone now? Okay, so yeah, sounds yes. So maybe Dung, if you can tell me if I talk and you don't see what I'm saying about, then maybe you should have warned me. Okay, so this is basically the course structures that like we discussed in Athens, and we put here, you see in this column, we put the source and the file where you can find in the share space where you can find the slides. So, and also what type of material we have prepared. So, for example, here we divided the things in 20 lessons, like a typical course for in Asia, in the Southeast and Sri Lanka is.
We have created a pipeline which starts, first of all, identifying the nucleus.
Oh, sorry. So that we'll start with the introduction. Yeah, the idea is to start the first lesson with a bit of introduction of what is AI. And here is really more trying to find the definition. The suggestion was at the time we prepare also the description to try to stimulate also students to understand what is the interest in AI, why people are interested, and what does it mean really actually AI. So one of the way one could approach it, what does it mean intelligence in general? So there one could try to see, to supply other material on what is intelligence. And I had a discussion with a colleague of mine, Max van Duin, who has a course on a philosophical aspect of artificial intelligence. And he suggests me, well, one way to approach this kind of lesson, it would be, why don't you start asking to the students what is intelligence, and instead of talking about artificial intelligence, why don't you start to talk about animal intelligence? So there has been a lot of study in biology on what is animal intelligence. There are very nice video on YouTube that everyone can download, and I can give a link if you want, on what is animal intelligence and how the perspective on what is intelligence changed with the time. So that is not comparing intelligence with the human intelligence, but just comparing intelligence on different aspects, on how things, capability of things that can be done. And that could be taken as kind of definition also on what is artificial intelligence. That is not always we have to try to mimic the human intelligence, but it can be also some augmented form of intelligence in general. Okay, so that could be some kind of lesson which is really just a start. It is just to stimulate students to think about intelligence. Of course, we are talking here, this is a basic course that should be on the first semester as no prerequisite. And yeah, so the students have no knowledge in general on what is artificial intelligence, but they have a background on computer science maybe. Then the second lesson would be a lesson dedicated to the history of artificial intelligence. Yeah, that's also quite interesting to see. Yeah, to just show, to start, yeah, from the past, when even before the real computing machine were existing, what kind of why how the people try always to mimic it, to try to find out a way of, for example, playing chess automatically, and this kind of games in general automatically. And this is supplemented by some paper, basically, that is readable for everyone. It's a paper about the history of AI. It's not very updated. It's from 2017. And this paper, yeah, it presents just the material on, yeah, just for everyone from reading about the history. Then we go more to the technical part. That is, on the third lesson, we start with the intelligent agents and search, the third and the fourth lesson. And here we use the book which was proposed by during the description, when we decided for the description of the course. It's a standard book, Russell and Norvig, and that's the nice things that they have done also. They already have prepared the lesson for that, so we can reuse the material that they have prepared already. So we move for some on what is the definition of intelligent agents and what are intelligent agents in general, and then we go to the another part where we start with the lesson 5, 6. We go to decision making. So decision tree. This so what are decision tree? How this can be used for making decisions and so forth. Also there of course they can be supplemented with the reading part. And here we have an assignment already that can be given to the students. So there is an assignment. Yeah, that there is a PDF with an assignment about decision trees. Actually, there are 2 assignments on decision trees. One one with data which must be downloaded, but can be mimic with your own data if you want to create your own data, and you can just create some source, and then the students have to write a program for making a decision based on algorithm that they've studied in the course, and then to make a decision and classify the data. Then we move to heuristic algorithm on 7, and okay, so that's also from Russell and Norvig based. And then we have the introduction to logic. So since we do not assume any knowledge on any pre-knowledge on the start of the course, so we have to introduce a bit about yeah, predicate logic and how to do inference on some format for a predicate logic, yeah, based on Prolog, of course, that will be later. Then yeah, so we have 2 lessons dedicated to this. it's a bit compressed, I must say, since I'm teaching logic myself. So I think that in one lesson in teaching all about logic, it's a bit not very easy, but it's okay. So there is a choice on what is propositional logic, what is predicate logic. So what are predicates, what are variables, and some examples of how to model some sentences, for example. And then in the lesson 9, then we have a presentation which is dedicated more on the proof rules and how proof rules can be used to have inference, to make inference reasoning about facts. Then, yeah, the idea is that this logic then is used in logical edges, and then from there we move on lesson 11. We are already halfway the course. We move to prologue. So here there is also in a very compressed way 2 lessons which introduce everything one should know about prologue. There is no special implementation of prologue in mind. There's just a very general idea about logic programming, and then this must be supplemented, of course, by some manual and some lab session where students can just start and programming in Prolog and yeah, learn a bit how to work with Prolog. So after that, indeed, we presented us. There is an assignment. Actually, there is more than one. So there is a file where there are some collection of assignments in Prolog, which of course can be extended as much as you want. There is a lot of things that can be done in Prolog, but this is nice to just for a student to learn a bit how to use different types of programming and use logic programming instead. So yeah, we already arrived to the second assignment and the lab session, and so for the lesson we start different things. We move now to reasoning with the uncertainty. So until now everything was about reasoning with facts, and now we reason with the uncertainty, and that means that we move to a bit of probability, introduction, a bit of a probability theory, and a very light introduction also, because again, nothing is pre-assumed, and then to using a Bayesian network for reasoning about probability, for example. Then also there is some an assignment, some collection of assignments, few assignments that can be done on paper typically, but could be also implemented in some language. And then we move to Markov decision networks. And also again, here we have 2 lessons that are dedicated to this. Also that for studying about probability and time. And since we are talking about time, so we are also moving to temporal reasoning, different form for temporal reasoning. And here is just a flavor of it, because more is coming in later in courses like knowledge representation, for example, where we introduce more extensively situation calculus and things like this. So here there are some introduction to situation calculus, for example, and an assignment which describe which can be used by the students for learning, applying the idea that's been described above. After that, we move to the last part of the the course, which is about planning and scheduling. So planning and putting planning in actions. And well, that's basically finish the course. And from there, we just give 2 examples of an exam that can be used there. Well, one has to be careful, of course, because these are exams which are from courses which are based on the same book, but the notation can be different, the material can be a bit different. So here, if someone want to use the example of the assignment, I was always to be careful that there is a translation step that need to be done to just adapt to the way that one presents the material. Yeah, all the sources were just mentioned. Well, you can find it here. So all the sources. The most important things is it depends on the labs that you are using and on the version of Prolog that you are implementing your lab that you want your students to use. That this version should be, yeah, the manual for that version should be available for the students. So here we have one Prolog reference manual, but yeah, there are several versions that can be used depending on what you want. I think this is what I wanted to say, at least for that. I don't know if you want to see some slides just to have a flavor of it, but otherwise, yeah, we can also start if there is any discussion, because I think this course is quite a standard course. But anyway, if you have any questions, please.
I myself wonder if it would be easier, you know, most of the slides come from Russell and Norvig, but some clearly not. And this is because it contains some topics that are not contained in Russell and Norvig. I wonder if it would be easier to kind of switch out those topics and just focus completely on the book of Russell and Norvig when teaching a course.
That's a very good point, actually, you mentioned, because this is what I mentioned at the beginning, that when we prepare in Athens, we prepare the structure, the description of the course. Yeah, sometimes you get over enthusiastic and then you start putting a lot of material. And it's exactly the lot of material that we put there is Markov decision network, temporal reasoning. These are things which, not temporal reasoning, maybe not, but the Markov, especially the probability part, that is, yeah, maybe a bit too much. But on the other hand, yeah, it depends on the level of the students. Okay, yes, they are master students, but how much knowledge do they already have? If they are already capable with just a little bit of knowledge on the probability to just have presented the Markov decision network and reasoning about Markov decision network already. So this is, I think, up to the teacher, but so that's why it's provided here. But I would say that I would agree with you that, Jan, that maybe the best is just to follow one book, that is Russell and Norvig, which is a very standard book, and then yeah, that one can just move from that. And having Prolog, okay, that's always a help, especially for the lab session. But that's basically it. Do you have any question? I can just show maybe one or two slides. Is there any specific topic you want to see?
Hello, Marcelo.
Yes.
I'm Masayu from ITB. I saw slides from lesson 7 about heuristic algorithms, but the content in the slide is about constraint satisfaction problem. Do you mean heuristic search strategies like A* or local search like hill climbing? Please explain about it.
Yes, let me just open it, because I don't know. I must say I don't know this by heart like this. And the slides have been prepared also by a colleague, Frank Takes. So let's just see. Wait, I have to open. You say lesson 7. Lesson 7, yes. Oh yes, it's yeah. Okay, let me just put this so that you can see.
If I may make a guess, looking at the slides and at the source, this is about heuristic search, because it includes backtracking, and that's a search technique that uses heuristics to guide the search, but it always goes back to the root node, so to say, to find the optimal answer. So there's in heuristics, there's this distinction between whether you make a greedy step using a heuristic or an optimal step, but guided in order by heuristics. And I think it's the second part, if I remember it correctly.
Yes, I think so too. I think that's about heuristic. I am trying to fight to share a slide. Sorry. That yes. So I can put okay. These are the slides in PDF. We have also, for this we have also the PowerPoint slides. Yeah, we used the format of prepared by Migno. That was very nice. So maybe I should show more that one. But okay, so this is, can you see this? Yes.
Yes, I can see.
Yes, so yeah, it's about constraint satisfaction problem, but if you go indeed in, wait, I'm moving, yeah, so in backtracking, you see, these are the typical example like Jan was saying, so that we have how to search into, in the search space, for example, how to search using backtracking, or some heuristics there should be, so yeah, some degree of some heuristic how to move it and the list constraint values and so on. So yeah, so that's why it's called a heuristic, but indeed it's constraint using of constraint for yeah, search for a search space.
Marcelo, this is
yes.
another from USJ Sri Lanka.
Yes, hi.
Yeah, with respect to the same questions with heuristic, now this is now in this chapter, only the constraint satisfaction problems are concerned. But in general, the heuristics can be applied into all the search techniques that is described in chapter 3, their search.
Yes.
So like this is A star and even depth first search, it is similar to CSP. And with the search, all of these, the heuristics can be applied. So we can add heuristic search, informed search there as well.
Yeah, you're right. And I think indeed, algorithm like A star should be present. I don't know, Jan, if you remember if he's there.
It's probably present in Russell and Norvig, but
yes,
I do not know if
I'm trying to find out. Most probably will be the decision-making part. If you give me 1 second.
Coming under search. Two kinds of search we have in chapter 3, we have only the blind search. So the heuristic search or the informed search is not included in the material. So it's better to add some informed search techniques as well into the picture.
Yes, yes, I agree. If it's not there, it should be added. I have to check if it is in some other slides. And my guess, if it is, that will be in the decision part. I'm just checking a second.
I think decision is about inductive learning.
Yeah, so that's inductive learning, yes. Decision tree, blah, 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 blah. That's all inductive learning. Yeah. Okay, so no, that's if it is not that, there should be at least. Yeah, absolutely, I agree with you. But this can be added.
And also another comment on now we are in the course materials. We are using this basically mainly Russell and Peter, to Stuart Russell and Peter Norvig book. Yes. So we have put the 3rd edition there. And now even the 4th edition has come, but we may be happy with the 3rd edition. So if you look at the chapter 3, then these slides are coming from the 2nd edition, which is a little bit outdated. So I guess that it is better because now if a student look at the book and they look at the slides, so these will be a little bit confused. In earlier versions, for example, now these actions available to the agent, they are described by using what is called a successor function. Now in the newest version, so it is separated into 2 functions, giving more flexibility. two functions like actions and then results. So
Yes.
all the algorithms given in with respect to these actions functions and results function, but in the slides, it is with respect to the successor function. So then there may be a bit confusion when a student refers both of these at the same time.
Yes, but that's exactly, yeah. Well, this is the customization that still has to take place. Yes, absolutely, you are right. It should be, if we use the third, even the fourth edition, well, then one has to be careful that this part of the slide, should correspond with the material also that the students have. Absolutely, I completely agree. It's very confusing if you have different notation in different parts. So, as I said at the beginning, this is just a start to just have the material on what you can present, but then every teacher has to see what is really using, and there you have to prepare the slide, the real slides, using for the course from there. So, and depending which version of the book, that was probably will be the third or the fourth edition of that, then one has to update the material in this way. I don't think that Frank is not here, but I don't think that there is any update of the slides in the third edition. So that's something we should do manually, probably.
For
The slides
third,
from
yeah,
1998.
For third editions, the instructor resources are available, but we need to request and get the resources. Yes, okay. But for the fourth version, it's not there yet because it just released last month.
Yeah. Okay. Yeah, I didn't know. Yes, that's
but it matters only for 1 or 2 chapters. We don't have to make a lot of changes.
Sure. And again, it's that for those chapters we change it, and if you use the book for the course, then they will give the material to the teacher without any problem. So it's available there. Any other questions? Because these are 2 good points you mentioned.
I have some idea. For AI language, I see the Prolog. Prolog is good because some lesson we talk about the predicate logic. That's the basis for the Prolog. But nowadays we face many problems implementing by Prolog. Don't forget that now we are in the 21st century. The breakthrough technology at the end now is a deep learning. But we are going to teach and learn AI in the first and second generation, something like that. So it's far from the future. Because now we talk about the application, the successful application and new technology or something like that. But I found that the content of our course shown in the Novik and Larsen textbook, these textbooks was launched before the deep learning. It's really famous textbook, but it's the past. Okay.
Okay. So
okay.
If I
let's listen a bit.
Yeah.
Okay. So exactly. Sorry about that because I
no. There's nothing to be sorry. I mean, it's an opinion and it's a clear opinion.
Something. Okay. The second thing is you talk only the Prolog as mentioned. Yeah. I ever implement the strategy by using the scheme list. Scheme list is belong to the MIT. It's very efficient language. Yeah, it's similar to the common list. It's very efficient, and I implement heuristic search. Even the A* is very successful in implementation. And we can use A* in many things, even the games games playing. It's a good in practice. The point is, I understand the layout of the course is we try to put some basis for students, but do not forget that we have to go with the new technology a lot. And if we can connect with the new technology with the presentation, students will get benefit from this a lot. At the end, from this course, we have to go to some basis of deep learning. I think about this. It's not end up with something that show up in the Norvig and Larsen textbook. This is just my point of view. Okay.
I can quickly comment on this. I completely agree that that Russell and Norvig is kind of I don't know, not the old AI, but the basis of AI. And when I was looking through the course structure, I was extremely surprised that there was no dedicated course on deep learning. However, I think in the curriculum, there is a big, even though there's no course on deep learning in the curriculum, there's a big component of deep learning. And it's a little bit hidden in the course, recent trends in machine learning. So students, I think, should learn about deep learning and reinforcement learning, and yeah, basically this. But they will learn it also, I think, in one of the elective courses, on which we will talk on Thursday. But yeah, so I think that even though it could have, you know, benefited from a more prominent name that attracts students more, I think it is covered in the curriculum, even though not in this course. Do you agree, or?
Yeah, I would add, in addition to what Jan was saying, about 1/3 of the machine learning course is also deep learning. So we introduce the fundamentals of deep learning in the first machine learning course in the first semester, and then the RTML course, the recent trends course, is about, I guess, I don't know what Jan thinks, but yeah, it's about 90% deep learning. So I think we have a good coverage of deep learning in the curriculum. Although, yeah, I don't know if maybe we need a course that is actually has that name. I'm not sure, but yeah, it is there.
Yeah. So indeed, I also completely agree with Martin Jan. That it's not prominent in the name, but it's prominent in other courses. And the idea of this course was exactly not to introduce those techniques like machine learning and deep learning, even data mining. There is nothing about that, because this is presented somewhere else. This is more the symbolic AI kind of things. The more classical, if you want, or old, if you want. Okay, I'm a bit old, I know, but it's more the old-fashioned AI, which still I think it's very important. The students should know, and that's why it's part of the core courses, because there are other aspects which are not covered by deep learning, which should be learned by all the students. And aspects like, for example, knowledge representation or the semantics web, that these are things where deep learning doesn't play at the moment any roles there, but it's very important to have logical representation of facts, of description of ontologies, for example. And there is important that the student knows how to use it to have an idea of that. Then about the use of Prolog, yes, I know Prolog is not the most modern language. Yes, absolutely, completely agree with that. But the whole idea is that we want to give the students just something that they have to learn as a concept, not as a technique of language. The language in itself is just a middle, but the students have to learn the concept of what does it mean logic programming. And Prolog is very easy and logical to use. Of course, there have been enormous improvement, and there are several versions of Prolog with several extensions and other languages which are all based on logic programming. But the idea of using Prolog is because it's easy, it can be covered in 2 lessons if one has a bit of knowledge on logic, and then people can just use for prototype. But they will never use it for real programming somewhere else. It's just an exercise language. On that, I agree with you. Yeah, absolutely.
Marcelo.
Yeah.
Anand. Now this AI course is actually on problem solving and planning. Remember, we agreed to rename that, giving a second topic, subtopic as this is AI problem solving and planning.
Yeah.
So if you remember, we after the visit and then we had a meeting and we agreed on having a subtopic for the course. So we name it as problem solving, AI problem solving and planning.
It disappears somewhere. It means let me just look at the description.
Machine learning is also AI, so then there was a confusion. So then also Professor Dung suggested also say the same thing. So this is regarded as a AI course, course on problem solving and planning.
Yes. Yes, it's more in the problem solving and planning, and the all aspects of the data. So deep learning, for example, they will not appear. I mean, it's also a decision that one has to take where to put the material in which course. The most important thing is that things like deep learning, machine learning, data mining should be present in a program on data science and artificial intelligence, and reinforcement learner, absolutely, deep reinforcement learning, that should be present, but maybe they are spread in other courses in this case. And here we are only focusing on the symbolic part. So I think with Ananda, yeah, we discussed this. I remember we had a nice discussion at the time.
Yes, we have already included this deep learning and reinforcement learning under machine learning.
Yes, absolutely.
Already there.
Yeah. Any other question or comments? Because the idea would be that then you can just start with these slides and prepare for the course, which I don't know, somewhere in except with the IT, the rest will be somewhere in November, probably. They will start October, November. So one can start with the slide, and then before the next meeting, hopefully in September, then we can discuss the new packet of slides that is coming for each university.
Hi, Marcelo. This is Ruan from Peradeniya. Yeah, can I make a quick comment?
Yeah, absolutely. Yeah, that's
I think since this is a master's degree in AI, and we have covered the other topics, the deep learning, the machine learning, reinforcement learning, vision, and all in other courses. And I think if we can update the materials based on the third edition or fourth edition, I think the content would be okay, I think. Yeah, we have to have an introduction course in AI.
Yeah, and then absolutely.
Yeah.
And we was discussing with Jan about this also. I think the material before it really crystallize, it has to, you want us to teach it. You have to teach it to your students, see how it goes. If there are some points where there are difficult or not, or it's too easy, and then one has to adapt for the year after to see how it goes. But so we have to start somewhere. So this is just a starting point, but I don't think a course is always stable and static for the rest of the life of a master. So that's it's a very dynamic process, which everyone will go and move and update the material how he wants. But indeed, I also expected that based on this very standard course, there is not much maybe to discuss, so like you say, Ruan. Maybe Matt, if there were some question about the if you remember well, we have 5 core courses, but each university is choose 3 out of 5, at least 3 out of 5, or is mandatory to have all 5? Do you remember that?
Yeah, I think the agreement was we should all have 5 required courses, but then there was a discussion that maybe we would replace one. We could have the flexibility to replace one of these 5 with one of the other electives. But yeah, I mean, in practice, we have to adapt the curriculum to each university. So that's I think that's fine. I guess I was wondering in how, I guess what Sartra is saying, right? Maybe if I could put it in a different way, I guess we're maybe having a little bit of difficulty seeing how the material in this course connects with the other material, right? And how it's useful in practice, right? So I guess, I don't know, for example, there are all these like famous planning applications, right, that have been really successful in the real world, right? So I don't know if it's possible to connect with some of that historical success. Actually, I don't know if, the extent to which these kind of AI planning systems are being used around the world today, but I suppose that they're quite deeply embedded in modern information systems. I don't know, but I'm just thinking if there's some way that we could connect it to the industry practice. Is that possible?
Yeah, I don't know exactly. That's a big problem, because I mean it depends also on the structure of the full master. That is. If you want to connect with things like deep learning, and the students never have seen deep learning before, yeah, most probably this course, artificial intelligence, would be one of the beginning, the start courses. First semester, first course they take it, because it's very basic. Yeah, so it's big chance they have heard of machine learning as a keyword, but they maybe do not know exactly what it means. Deep learning, maybe they heard also, but no idea what does it mean. So it's hard to make during class at this level, make a connection of saying, yeah, this could be used in connection with deep learning or other technique. It's just very speculative. To make connection with industry, like you are saying, yeah, maybe that. One there could say absolutely that I think that one could say that this kind of technique can be used for describing, for example, ontologies, describing what is called the semantic webs, or robotics, moves of robots, or understanding and knowledge of agents in an environment which can be uncertain or not, and remaining a bit vague, of course, because that's not much that you can say there, but and that these things can be a bit more explained in a course like a knowledge representation, that they are more expanded there, this part of the course. And then, well, the connection with the industry, yeah. I mean, if you say something like robotics, probably you already have a connection with industry, but make a clear connection, or about planning. Yeah, and planning is a very good example too. But also there, if planning, there are nowadays better techniques like evolution algorithm work much better in planning than using planning and using logical construction. Still, it's something like, yeah, sometimes you have to go through maybe old-fashioned things to just learn a technique that then makes your horizon more broad, and yeah, you can be more open to other things too. So yeah, the connection to industry it's a bit more complicated to do at this moment in time. Maybe with the knowledge representation is better, but connecting this way, saying that yeah, this reasoning and planning can be used and are used in some way outside the world. Okay, now I'm trying.
Marcelo, Matt, may I add something?
Yes,
maybe if we think that there are some overlapping, huge or tiny overlapping, or some specific subjects are missing, would you like to see the machine learning and the AI course to see what is missing or where is the overlapping part? And maybe having an idea what we would like to add in each one of these courses or what we would like to take away in order to be sure that we will have all the algorithmic part and all the exams that Matt asked me for. Do you want?
I think there's no, we can safely say there's no overlap, right?
So, okay.
Yeah.
Okay.
Yeah, that's okay. But then as far as things that are missing, yeah, we're certainly missing plenty of things. We cannot do everything in a one-year coursework, right? In both of these fields. But,
okay.
Yeah.
And I think if there is a bit of overlap, it's not really bad. If the students hear twice the same concept.
No, it's not bad.
No.
Just I was thinking to see if we would like to change something.
Yeah, I agree with Marcelo. We need some overlapping because Prolog we studied in the 80s, 90s, but nevertheless, some overlap can be good if you have some assignments that are attractive for students.
Okay, yeah, maybe today we finish earlier. That's not bad, by the way. Especially for people from Asia, that's very late. I see all dark from the windows.
A little bit sleepy.
Yeah, because we just had the lunch. Huh?
It's still not 1 o'clock, so I'm waiting for lunch.
Okay, I think maybe we can conclude here. So,
can I say something?
Yeah, absolutely.
What do you teach logic in two sessions? How many hours you plan, and how deep you are going to go? When you say the first logic, if you go straight to first order logic, predicate language, then there are a lot of students who get lost. Right? Yeah. But if you go through proposition and logic, when it would take you many hours, right? And when you go to inference, what kind of inference you plan to teach? Because different inference system convey different idea. So if you are going to inference and you connect it to Prolog, you probably would have to do unification. Yes, yes. But unification is not, it's nice, yes, but there are many other methods. I think that may turn out to be much more intuitive. Why then when people now talking about you got a set of rules, and when you want to apply that, then you would have to set up arguments, because the rule of law are very conflicting, right? When the reasoning is not unification anymore. So I think that because when the structure, especially if you do later in real application, it's going to be non-monotonous logic, right? So in that sense, it's, if you teach unification, it is nice, but when it's difficult for people to connect, the unification cover, I mean, somehow hidden. The structure of the reasoning is hidden. You got a number of combination, but the structure of the entire reasoning tree is not fully clear. not fully clear. And that would basically when you can explain prologue, but actually at the beginning people think prologue came for unification. Fine, but if you look at the semantic of prologue, when it doesn't really came for unification anymore, because the semantic of it, if you use unification, you cannot explain it. That's the reason why for more than 10 years, people develop different kind of semantics for prologue, and nobody see connection between them, right? Now, because unification cover, hidden, hide the structure of the reasoning. Yeah. And if you incorporate let's say, we call it default reasoning into that. At certain points, when you cannot do that. So that basically, if you teach unification, you make it difficult for students later to connect to more powerful system. Yeah. I mean, more advanced logical agent, put it that way.
Yeah, I think I could not agree more with you than what you say. That the problem here is a kind of compromise. So if you ask me indeed how much hour do you plan to teach logic? Yeah, as I said at the beginning, that's I teach logic myself. I used actually this year I finished. I used to teach logic myself, full course, 26 hours, and I only introduce propositional and predicate logic, not even prologue. So it's I can cover with 26 hours course. I can cover only these two topics, and because and it's not enough. I mean, even there, you also know there is the world of logic is much more than just propositional and predicate logic. So in this course, unfortunately, is just a course which is a kind of a container where we put all symbolic technique for artificial intelligence, and one is just the use of Prolog, which I think, and I think you also agree that is the use of Prolog is something which is for the students interesting and relatively easy to learn technique, just to implement and write a little program that can just show you how the symbolic word works. And this is based, I mean, for this course, at least for the slides like they are based on unification. There are other systems that unification is not the only and the most central part. I completely agree with you, but this is, for the moment at least, is out of scope. It would be interesting at least to mention this. If I would teach the course, I would at least mention this to the students, interested students, then could go deeper and deeper and even writing a thesis for that on this kind of work. But that's up to the teachers. I cannot say anything there. But yeah, I agree. It's unfortunately, we have to put all this material in one course and having only 2 hours, so 2 hours only for teaching the predicate and proposition predicate logic. And I already expect a lot of difficulty in the predicate part. Propositional can be easier, but the predicate part could be quite complicated already. And on top of this, in these 2 hours, also have this inference rules based on Horn clauses and unification. So a more algorithmic part, I would say. So I don't have a I mean, if you give me the time, give me all the time what I want, and with you we can make a course of 50 hours on all we want. Anything?
Question, Marcelo?
Yes.
Can you hear me? Taufik.
Yeah. Hi,
based on your course material, you wrote on the lesson 11, you start teaching Prolog, while you also mentioned on the other course outline that all the lab activities will be using Prolog. Do you think it's a little bit late to introduce Prolog on lesson 11 instead of, is it better to move it to the beginning? Because you're going to use all the assignment and also all the lab activities using Prologs. So when you put Prolog on lesson 11, 12, and so on, I think it's a little bit late. What do you think?
Yeah. Okay. So the assignment at the moment, as they are presented, they could be done on pen and paper, say. So if you want to do this on by programming and Prolog, especially the one on decision tree, for example, then yeah, one has to move it earlier. And this could be done without, I don't think there is any problem in doing this. That could be that immediately after intelligent agents, or even before that, one can start immediately with the introduce predicate logic and then Prolog. I think that the idea of having first intelligent agents is to give a bit not to scare too much the students by presenting immediately a dry things like logic, but just to give more a flavor of what could be used and where is the intelligence part here, and then present the logic as the reasoning mechanism of the intelligent agents. So it could be moved in lesson 5, for example. Could be moved.
Yeah. Okay. Because otherwise, for the lab activities, what is the lab activities for lesson, let's say lesson 3 to 9 or 10?
Yes.
Yeah.
I think can be moved easily in lesson 5. Yes, I agree with you.
Okay, thank you. Yeah, just a suggestion.
Thanks. Very good suggestion. Okay. Then, Matt, if you want to close, I will just say, we see tomorrow.
Okay. Yeah. Is everybody sure that they're exhausted and no more comments and questions? Okay. Yeah. So thanks a lot to Marcelo for introducing this course to us and for the discussion. And I guess we will continue tomorrow. I guess there's one small announcement. The SkyBridge team finally got the connection to AIT Zoom working with OpenEdX, with the VLE server. So we hope that we'll announce the Zoom meetings through the VLE tomorrow. So then at least we'll get to see how the VLE supports us to create Zoom sessions and so on. And also, I hope that we'll be able to start to upload some of the material to the VLE as well. So anyway, so hopefully we'll see some progress with the VLE tomorrow. And yeah, I think that's it. I think we have one more core course tomorrow, right? DMM, and then we move on to the electives. So it should be fun. Any other comments or questions? Oh, one other thing is the evaluations for these sessions. So at first we thought that maybe we would have just one evaluation, but then there was a suggestion that we should have separate evaluations for each of the sessions, right? So what we're trying to do now is to make the Google form so that you don't have to write on paper and scan it or something, right? So we'll create Google forms for the evaluation. So we're working on that now, and then so then we'll ask everybody to please contact your colleagues and get them to fill out the evaluation forms for the sessions that they participated in. So that would be important for the evaluation and feedback. Okay, no other comments, then we meet again tomorrow.
Okay, see you tomorrow.
Everybody.
Bye-bye.
See you tomorrow. Bye-bye.
Thank you, Marcelo. Thank you, man.
Thank you.
Bye, everybody.